This is a painting by Claude-Joseph Vernet. It shows road building in France in the 18th century, when all work was still carried out by hand. There's a group of engineers in the middle on horses, and the foreman is giving a report about the worksite in a servile manner. 250 years later, we have the age of compact asphalt technology. With Dynapack equipment, two types of asphalt mixes can be paved at the same time with a performance of 1,100 tons of material an hour. Dynapack compact asphalt technology is the answer to your needs when it comes to cutting construction time, improved quality and economic benefits. What is the current traffic situation? A continuous increase in traffic volume, a rise in axle load, a rise in heavy goods traffic. The road becomes the warehouse, and the consequence, more and more traffic jams with significant disadvantages for road courses. In contrast to this, we've planned the lifetime of road courses. Wearing courses, 10 to 15 years. Binder courses, 15 to 25 years. Base course, 40 to 50 years. And roadbed, 50 to 100 years. Usually you'd have to replace the wearing course twice in 25 years. With compact asphalt technology, we can prolong this lifetime to the lifetime of the binder course, and this is very economical. Have a look at some current problems. Roads become greasy, problems with evenness, problems with grip, problems with deformation resistance, potholes. And there are also problems with interlocking between the courses. The cost of repairing our transport network has reached gigantic proportions, with public funding hardly able to cover this cost. Economic future prospects. Depending on the ability of traffic systems and the power of the mobile economy to compete, there is no end to traffic growth in sight. The road is by far the main means of transport. In Germany, 70% of goods are transported by road, and traffic jams are an increasing burden for the community. The budget can only be maintained in the medium term by improving quality. The aim, a long lifetime combined with minimum maintenance. And quality can only be achieved when you strive for homogeneity consistently. Compaction efficiency is greatly influenced by the temperature of the asphalt mix. The following animation shows degree of compaction as a function of the number of hits from a Marshall hammer. The red line indicates the theoretical degree of compaction achieved at 150 degrees Celsius. 100 hits results in a degree of compaction of over 101%. The following two lines indicate how sensitive the asphalt mix is to temperature during compaction. To reach a degree of compaction of 98%, 100 hits at 120 degrees is required. You'd need the full fault energy to get the same result. If the temperature falls to 100 degrees or below, even full fault energy isn't enough to compact the asphalt on 97%. The void content is almost 8%. This is normally the case in the cold season. That's why there are problems with the compaction degree, the void content, and the interlocking of the courses. We know the results very well. Short lifetimes. Let's take a look at how a conventional road is constructed, with its separate layers depending on use. And in comparison, the compact asphalt. The cooling of the thin wearing course is slowed down because it's laid onto a hot binder course. Therefore, a longer period of time is available to reach optimum compaction. The high compaction achieved also results in high deformation resistance due to the tightly set grain structure between the two top layers. Here the binder layer is colored green and the wearing course red. You can see the extensive linking and covering. According to the Technical University at Darmstadt, the result is 37 kilonewtons cut power. This is an increase of about 50%. To better clarify the demonstration, we've placed aluminium foil between the two layers.